So hello everyone, welcome back and let's start. So in the last session we discussed about the Docker and why we need to go with the Docker, and we have discussed about the virtualization also. So what is meant by virtualization, and then we discussed about the physical server virtualizations and these things. So to make you understand, I have I just installed my so in the last session, whatever we have discussed about the virtualization, what we have discussed, a virtualization is a concept of converting or else accessing a physical server into logical servers. We can make a single physical server into logical servers, and these logical servers will utilize the resources from the physical servers. This is the concept that we have seen in the last session. So in this session, we are going to discuss more and more about the concept of virtualization, and then we will go with the containerization. Okay, so hold on. So if you can see here, this is my Windows 11 operating system where you are having somewhere around some 32 GB of RAM. You can see the 32 GB of RAM is there, which is right now is in 17.5 GB is consumed. Okay, why it is consuming? Because I am running two virtual machines on my virtualization software. Here I am having a VMware. So in general, virtualization is of two types. Before we diving into the containerization and all the concepts, so I hope you, whoever has been attended the last session, the same people are attending today's session also, if I am not wrong. Any new joinees are there? Before I dive into the concept of virtualization and then containerization, I just want to ask you about this. Any new people? Okay, so you are new today. Okay.
Yeah. Hello. Hi, Chaitanya. Hi, Chaitanya.
Yeah,
This
hi.
is Manon here. Yeah.
Yeah, hi, Mano. So yeah, just introduce about yourself, and then are you so just introduce, and then I will pose some questions and we will have a conversation, and then we'll go into the topic.
Okay. Yeah. Yeah. My name is Manohar. I'm working in one of IT organization. I have experience of around 10 plus years.
Mhm.
Currently, I'm working into IT infrastructure related product. So I'm just looking for a new career so I can go for the regarding toward the clouds and DevOps side.
What is
So
your base role? I just want to know about your role.
yeah, role is like infrastructure, ITSM. We're going to maintain service management, ticketing tool for IT organizations.
Okay,
Yeah.
understand.
Yeah.
Yeah, good to know. So you are about to change your containerization, like you want to learn the containerization to upgrade your skill sets. That's it, right?
Correct. Yeah.
Yeah. Okay, so now we will be discussing about this virtualization concept, and then we will go into the concept of containerization. And then so I don't want to prolong very much extended about this session. I just want to keep it so simple. So in the upcoming time, we will discuss about more in deep into the Docker concept. So as of now, if you see here, there are two types of virtualizations. One is the hosted virtualization, and the next one is bare metal. First one is bare metal virtualization, bare metal, and the second one is hosted virtualization. Okay, or else we can call it as type 1. The bare metal is also known as type 1 virtualization, and hosted virtualization is also known as type 2 virtualization. Type 1 Hyper-V and type 2 hypervisor, they will call like that. We can call it as type 1 virtualization and type 2 virtualization. Now, when we are coming with the bare metal virtualization, what will be there in the bare metal? So, I'll just go with the diagram again. It's very this. So here you can see bare metal versus hosted. Okay. So if you can see the differences over here, what is the main difference between bare metal and hosted hypervisor? Uh, think this is a perfect example for all the things. Just so let us concentrate only on these two, bare metal and virtual machines, hosted virtual machines. Then later we will come to the containers. Now in the bare metal, you will have the hardware. Hardware is nothing but your CPU resources like CPU, RAM. These are all comes under the hardware. Okay, storage and all the things will comes under the hardware. On the top of that, so here there is a mistake. The mistake is there is no host operating system. So we will use the virtualization platform itself. Either it might be VMware or else it might be Citrix like that. Okay, VMware ESXi or else Citrix we will use. On the top of that, we are going to install the virtual machines. I think it's totally, no, this is not a perfect image for you. Hardware, hypervisor, yeah. But this is about the containers again. No, this is not a proper explanation. It's not there on this also. Let me explain you through the diagram. So now what will be there in the bare metal? So when you see the bare metal hypervisor, you will have the hardware. On the top of that, you will have the virtualization installed. Either it might be VMware ESXi or else Citrix Gen servers or else hypervisor, Windows hypervisor, anything like that. Okay. On the top of that, we are going to install the virtual machines. Okay. So the each virtual machine will have its own operating system. On the operating system, we are going to install the applications. So this is how a typical bare metal hypervisor will be looking like. Okay. Or else bare metal virtualization will be looking like. So like that, you will have multiple VMs. Okay, here I am just showcasing you only two VMs, but if you see the bare metal, there will be so many virtual machines will be there. So what are these all things? This is the hardware, and this is the VMware or else virtualization platform like VMware ESXi, or else I can go with Citrix, or else Windows Hyper-V. These are all comes under this virtualization category. And on the top of this virtual machines, we are going to install the, on the top of the virtualization platform, we are going to install VM1. On that, we are going to install an operating system that is Windows or else Linux, any. On the top of that, we are going to run the application. So app1, app1. So here you will have VM2, and I am going to install Linux, and here you will have app2. Okay, so this is about your virtualization platform. Okay, so hold on, I think stop. Right. So what is the main difference in this configuration? If you see here, what is the main difference here? So the next one is, this is the bare metal hypervisor or else bare metal virtualization. The next one is hosted virtualization. What is a hosted virtualization? Everything you will have in the bare metal, the same you will have in the hosted also, but the main difference is you will have the hardware. On the top of that, you are going to have an host operating system. On the top of that, we are going to install the virtualization platform like VMware Workstation, like that. On that, we are going to install the VMware or else virtual machines. So this is the virtual machine 1, virtual machine 2, and virtual machine 3. Like that, we can install number of virtual machines. On the top of that, we will install the operating system. Either it might be Windows, Linux, Sun Solaris, like that. It's your wish. On the top of that, we are going to install the applications. So this is totally your hosted hypervisor or else hosted virtualization. Now we are seeing in a very good perspective. So if you can tell me what is the virtualization that I am using on my system, hardware, host OS, and this is like VMware Workstation, and this is VBox. Like that, we are going to install everything. Okay, so there is another option called as KVM is also available for the Linux operating systems. Here you will have VM1, and here you will have guest OS. This is called as guest OS. Whatever you are installing on the virtual machines, that is called as a guest OS. Now, if you can see here, the host OS of my system is Windows 11. The host OS of my system is Windows 11. So on the top of the hardware, I install the Windows 11 operating system, which is a host OS. On that, I have an application called as VMware Workstation. On top of that, I have installed the Ubuntu machines. So whatever you are seeing here, this is the Ubuntu operating system. You can see here cat/etc os-release. See there, it's an Ubuntu 2204 operating system. So it's a virtual machine which I am using now. So now if I shut down this, if you can see here, what is the resource utilization? The resource utilization is up to 18.6 GB. Okay, so the RAM I am showing you. I will try to power off this particular server. When I power off the server, look at here, slowly the memory consumption will be reducing. You can see here. So still you are seeing 18.6 GB. Now it is getting down to 14.4 GB, which means 4 GB of memory consumption has been reduced. There is one more virtual machine here which is running, that is node 1. So now what I will do, I will also shut down this node 1. Okay. When I shut down the node 1 also, what happens to the resources? So the resources 14.5 GB is there. Now it is going to reduce to 12.3 GB, 10.8 GB. So it is getting reduced to very, very low. Okay. So right now it is having 10 GB. So which means that from 18 GB, the resources has been dropped to 10 GB. Okay. So here the CPU consumption is also reduced, which means that what did you understand from this scenario? So the virtual machines, whichever you are seeing here, what they are accessing, from where they are accessing the resources, they are accessing the resources from the physical machine. Okay, understood about this point, guys? Hello.
Yes, understood.
So moreover, the most important thing here is, so whatever the virtual machines that we are creating, these virtual machines will have a guest operating system. So they are very huge in size. Okay, whatever the virtual machines that you are seeing here, they are having the guest operating system. Now, if we want to pack this virtual machines, I will try to pack the virtual machines. I will go to VMware Workstation Pro, and then I can take a snapshot of the entire virtual machine. Right now, whatever the physical state is there, I can take the snapshot of that. Okay, here you can see there is an option called a snapshot. When we turn on the machine, you can take the snapshot, but the size of that particular snapshot will be very high. Why? Because you are having the entire operating system itself. You are having the kernel, you are having the operating system. We discussed about the kernel in the last session. So due to that, the image size will be very, very high, around 20 GB, 30 GB of size will be there. So if you want to migrate this amount of data from one location to the another location, so if you want to transfer this data, it will take some time. So now to overcome all these hurdles, we are going with the containers. So containers are lightweighted. So why we are going with the containers? So if you can see, uh, Docker containers versus virtual machines. Look at that. What is the main difference between the virtual machines and the Docker containers? Virtual machines and Docker containers are two popular technologies used for running the applications. Both are helpful for us to run the applications itself and in the isolated environment. What is this isolated environment? Which means that the virtual machines which we have created, or else the containers that we are going to create, will be they. So if there are two or more containers are there, so the applications that is running in one container will have its own container. Okay, so it will not work with the another container. So the resource sharing will not be there. Okay, we'll discuss about that. But as of now, they are isolated in the environment. While they serve the similar purpose, they have a distinct differences in how they achieve the isolation, resource utilization, and portability. Let us discuss about the virtual machines. Virtual machines emulate a complete physical computer, including the hardware component that has such as CPU, memory, storage, and interface. So they are going to get the resources from the physical machines from starting onwards. We are talking about the same. And resource overhead. So what is meant by resource overhead? VM have higher resource overhead compared to the containers because they replicate the entire OS stack from the VM. So that is what we are talking. So it will have the entire operating system which has to be packed. So that is the reason why it is overhead. Overhead in the sense it is weighted. Now, if you go to the containers here, Docker containers provide lightweight, portable, and scalable environment for running the applications. Now I am having a virtual machines which I am running right now. So suddenly the load on the virtual machine is increased. Okay, so if you are having, for example, there is an Amazon website which is hosted on the virtual machine. Try to understand this. So you are a very good corporate employee and you are working under an e-commerce website. So now what you have done, you have installed the e-commerce website in the server, okay, in the virtual machine. Now everything is going well. Routinely, everything is going well, and there is no huge amount of resource consumption is there for your servers. Everything is going according to the plan. Suddenly, your company has announced a very good sale. There is a great Indian festival sale, or else there is a very big sale which happens only once in a year, where you are going to reduce the cost of the entire items. So then you are having your application on a server. You are having your application on a server which is running. So now general traffic will be there until you announce the thing, until you announce the sale, flash sale or else any sale, the traffic will be very normal. When you announce the sale, what about the traffic on the servers? When you announce the sale, what about the traffic on the servers? Yes. When you announce the sale, just imagine. Or else, see, there is a shop. Okay, there is a shop, cycle shop, or else there is something like computer shop is there. Okay, so in general, they are giving the laptops around 40,000. So for CPU or else 8 GB of RAM laptop. Okay, i5 processor, 8 GB of RAM processor, 8 GB of RAM. They are giving somewhere around 40,000. At the normal days, there will be no people, no customers will go across that shop. Okay, so now suddenly they have introduced a sale where they are going to give the laptop for 25K. Now, what about the traffic? What about the traffic to that particular shop? What about the customer flow for that particular shop? Whether the customer flow will be very high at the normal time or else at the sale time. When
At
it
the
will be
same
high?
time. At the
At the
same
sale
time.
time, the
Yeah.
customer flow will be very, very high. Whenever at the sale time, the customer flow is high, if the shop is very small, whether the owner will satisfy the customers, the shop
No.
is small, so it is not possible. Okay, inside the shop there is only one employee, so it is something trouble for that employee to satisfy each and every customer. So in the same manner, I am having an application which is running in a server and the load is there. Suddenly, if the load on the server is increased, the server cannot handle the load. So now what I have to do in the same scenario, if I am having only one employee, I cannot withstand the load. So I have to recruit another employee. Okay, depending on the load, I have to recruit another employee. Okay, so for my shop, I have recruited another employee. So he will be sharing the load with the previous employee. So now what happens? The load, so the employees will share the load. Everything is fine. Now the sale has ended. Sale has ended. So now, is any benefit for me or loss for me? Can you tell me if the sale is ended? Now, what is the loss for me? Pros means I will get a huge number of traffic. Sale will be super hit, and all the laptops will be cleared out. What will be the con? Like disadvantage?
The employee you hired extra.
Yeah, exactly.
Yeah.
So I have added an extra employee. He will be an extra burden for me. I have to pay for him. In the normal days also, I have to pay for him. So in the same manner, if there is a single server is there, now when the single server is running, suddenly the load is increased. Obviously, I have to purchase a new server and I have to add the server to the old server so that the load sharing will happen. After the load, what about the second server? Do I need to use that? Of course, the load sharing will be done, but the resource consumption will be very, very, very less. So we don't need the second server, but unfortunately we have purchased it. So there is economical loss, and as well as the resources will be misutilized. So this is a problem. To overcome that, what we are doing, we are going for the containers. And the most important thing is, if you want to run that server, you have to install all the applications. First of all, you need to install the operating system. Like if you are getting an employee, so you have to train that employee in all the specific manner. So you have to receive the guests like this. You have to sell the laptops like this, and you have to give the discounts like this. Everything should be teach. In the same manner, if I am creating a new server, everything has to be built from the scratch. Okay, built from the scratch. So it will take so much time. So when it is taking so much time, the what happens to the previous server? That will be dead. Before this server is up, due to the load, that will be dead. So there is something difficult with the virtual machines also. So to overcome this problem, we are going with the containers. So containers, whatever we are creating, they are lightweighted. Containers are the lightweighted. Containers are nothing but the processes running in your operating system. So what is a container? Container is also a process. Okay, it's like a application process that is running inside your operating system. That's it. So, but the main benefit of the container is it is lightweighted. So if you want to create a container within 2 seconds, you can create the container with the help of an image. You don't need to carry 30 GB, 40 GB of image. If you are having somewhere around 500 MB of image also, it is going to create the container. So it is not a very big deal. So very easily you can create the images, very easily you can run the containers. If you want to scale up the containers, what is meant by scaling up the containers? If there is a load on the container and you want to increase the number of containers, you can easily increase the containers. If the load is less, you can decrease the containers. So auto scaling or else scaling we can do, either increasing of the containers or decreasing of the containers, we can do that. So that is what they are saying. Containers provide lightweight, portable, and scalable environments for running the application. Unlike VM, containers share the host system's OS kernel. So VM will have its own operating system and its own kernel, due to which it is heavy weighted. When you come to the containers, what containers will do? So containers will work with the host operating system kernel only, which means that, look at here. If you see this diagram, you will understand. So for all the virtual machines, you want a guest operating system. In this second virtualization type also, you need the guest operating system. But when you go to the containers, in the containers, you will have the hardware, host operating system. You will have the hardware and the host operating system. Sorry. Host operating system, either it might be Windows or else Linux. On the top of that, you are going to create a Docker engine, containerization engine. Either it might be Docker or KT, like that. There are so many containerization engine platforms. On the top of that, you are going to create the containers, and these containers will run the applications. So here we are skipping the guest operating system. So then how management will happen? So now this container will communicate with the host operating system. Inside the host operating system, you will have the kernel, host kernel. So the containers will run with the help of the host kernel only. So separately, we don't need to have a separate kernel for the Docker containers. If you have the host kernel, so the container will request the host kernel to manage the resources for the container applications. Okay, so the host kernel will manage the applications with the, or else manage the hardware for the applications that are running in the container through this host kernel. This is about the containers. So that is the reason the containers are heavy, less weighted. So that is what they are trying to say you here. Okay. Unlike VMs, containers share the host operating system kernel and only include the application specific dependencies and libraries. So if you see the operating system will have its own dependencies. Operating system will have its own dependencies and libraries. And when you are installing the application will have its own dependencies. Application wants AMD 64 processor. Application wants something like one application will be depending on the another application, like that. So application will have its own dependencies and operating system will have its own dependencies. But here, when we are skipping the operating system, now there is no OS kernel is there, so only applications are there. So inside the container, we need to install the dependencies for the application only. We don't need to install any dependencies for the operating system. So we are reducing the entire requirement. We are only working with the applications. We are not going to working with the operating system. We are not going to worry about the updates, operating system updates. Okay, so if we are using the virtual machines, we need to check the updates every now and then we need to monitor the security, or else we need to check out about any dependency things. Okay, but in Docker containers, as we are skipping the entire operating system, we have to concentrate only on the application. Okay, so this is about your Docker containers. So if you can see, virtual machine technology emulates the complete physical computers and OS level virtualization. Docker containers will be working on the OS level virtualization. Isolation and resource overhead will be there. Hypervisor, so whatever they are using. So they are just saying the differences between the virtual machines and your Docker containers. So this is about the basic concept of why we are going with the Docker containers. So I will try to show you whether the Docker desktop is turning on. I will try to show you how to create a container in the Windows. Let me show you that. Or else I will create another Ubuntu machine in my AWS account and I will show you how to create the container. As these are the demos, take them like a demos only. Don't go very in deep into this. We will discuss about the in deep discussion about the containers, Docker, when we started our physical, the original sessions. Okay, so hold on. It has to start, but that's okay. Now what I will do here is I will go to my AWS account. In the AWS account, I will deploy a server, and inside that I will install the Docker. So I am having an AWS server over here. Let me run that server. Already Docker is installed on the server. So it is a Mumbai location. Let me go to another region. Okay. So I'll just show you how much time I will take to create an application within a short span of time. How I will run the instances in the Docker container. Okay. How I will run the application instances in the application in the Docker container. That's it. So hold on. Yeah, good. So what I can do here. I'm able to access my server. If you can see, hold on a second. I'll try to access my server. Good. So already there is Docker installed. I will show you how to install the Docker in the next session. So, but as of now, so if you can see Docker PS. Okay, so I don't have any sort of containers running. What is this Docker PS? Each and every command I am going to give you an explanation, and as well as I will provide you the document also. Don't worry about that. So Docker run hyphen itd hyphen name, which means I am creating a container hyphen name web app, and what I will do, I will give the image also. Chaitanya Manikumar slash. That's a problem. I know that. Test container version 1 hyphen p80 colon 80. Or else I will go like this. Hyphen p. What is this hyphen p? Each and everything you will get a clear-cut explanation. Don't worry about that. ITD, right? So my fault, ITS. Right. So hold on. Okay, good. So now we have the container. which is created. So within a second, within short span of time, I have created my application with the image. So how we are going to generate this image? So you are using an image called as Chaitanya test container version 1, from where you are getting this image and how we are going to work around that image. So is there anything that we need to understand? Yes, you have to create the image. We will create the image. So if you can see Docker PS, here we have a container that is called as web app. Now, if you go to that server and run the server in the web console, you are getting the application like this. You are getting the application. So if you delete the container, Docker rm-f web app, I am deleting the container. If you refresh this, the application is gone. Why? Because the container is deleted. Inside the container, you will have the application. So as the application is deleted, we are unable to access the container. Okay. So see how much simple it is. Within a fraction of second, I am able to create the container. Within a fraction of second, I can modify the container. So here the basic concept is this image is very necessary. So how we are going to create this image, that we will discuss in the syllabus. Okay. So when we go into the in deep into the concepts of Docker, we will understand that. Now let me introduce you the syllabus first, and then we will discuss about the remaining concept. So what I will do here is I'll go to the so here we are going to discuss about the entire Kubernetes. So this is my customized syllabus where we are going to go with the Docker. First of all, we will understand Docker containers, Docker engine, Docker networks and images and registries. Later we will understand so in the for Docker itself, if you see the Docker syllabus itself, that is phase 2. So here you are having phase 1. This is the Docker syllabus which we are going to cover. Introduction to containers and Docker architecture and Docker repositories, pull, create and upload the Docker images using Docker file, how we are going to create the Docker images, understanding the Docker networks and understanding the Docker volumes, and creating a Docker cluster using Docker Swarm, and then container placement, node availability, rolling updates. These are all the small concepts which we are going to cover. You don't need to worry about this Docker. And then when we go to the Kubernetes, so in the Kubernetes, we are going to discuss about the creating the Kubernetes cluster with the help of kops and creating the Kubernetes cluster with the help of kubeadmin, rancher. So these concepts we will cover. And later we will discuss about the primary components of the Kubernetes and the deployments. Later we will work with the Kubernetes services. So these pods and deployments, replica sets, very important for you. So without deployment, we cannot work with the Kubernetes. Okay. So and then we will discuss about the Kubernetes services, which are going to expose the application for the end users. So if there is an end user and how we are going to expose the application for the end users will be understood by the Kubernetes service. And advanced scheduling. Okay, and then so here we need to understand the basic of Kubernetes architecture. So if you understand the basic of Kubernetes architecture, you will understand the advanced scheduling also. And then we will discuss about the Kubernetes storage. Later we will discuss about config maps and the secrets. So if you want to store a password in the encrypted manner, then we will go with the secrets. And then securing the Kubernetes cluster with the help of RBAC tools, role-based access control, and then troubleshooting with the help of monitoring tools we are going to work around, and then rancher and K3s and network policies, and finally Helm charts, monitoring and logging with the help of Prometheus and Grafana, and ELK stack. Okay, Elasticsearch, Logstash, and the Kibana. We will understand with that, and we will see the logging also. And then AWS integrated Kubernetes services, managed Kubernetes service we are going to work around. And finally Helm charts. So this is the syllabus which we are going to cover in the 40 days of time with no failure. Okay, so that's about the entire syllabus of your entire Docker, whatever the technology that you are going to learn, Docker and Kubernetes. So with the help of this concepts, I can say you that you will be eligible to clear out the CKA certification, certified Kubernetes administrator certification. You can clear. Okay, so that's my promise. Like I just give you a word of you, like word of word that you can clear the certification. So that's about the Docker and Kubernetes syllabus and what you are going to learn in the next upcoming 40 days. If you have any further questions, you can ask me now. Yeah, next 10 minutes, entire questionnaire. You can ask me any questions. I will answer you the answer your questions.
Okay, like in to work with the Docker and Kubernetes, do you need an AWS machine, or I have an Ubuntu VM installed, like artifact VMware guest OS?
Single
Is
Ubuntu
it
mission is not sufficient for the Kubernetes. Why? Because I am not going to tell you in the mini cube. So
oh,
whatever the Kubernetes that we are working, the Kubernetes will be in the production environment. Like we are going to literally create a cluster. Inside the cluster, we are going to work with the pods.
okay?
Yeah. Abhishek, actually, I have an AWS session in the evening 7 o'clock, but it is somewhere around 20 days of session has been completed. So you have to wait for another couple of weeks.
Yeah, Chaitanya, I have one question here. Like a bit confused with the DevOps and Kubernetes and Docker, how it's going to fit in the cloud. So I'm a bit confused,
Okay,
about.
DevOps is
Yeah.
totally it's like implementation phase. Okay, so whatever, it's not a single subject, it's a methodology. DevOps is a methodology, which means that you will have multiple tools which you have to work around for the DevOps for implementing an application. You are having an application, Java related application, or else any application. So to develop that application, you require the version control that comes under the Git, and then you require certain tools like SonarQube and then Maven and then npm. So these tools will comes under the build package manager. Later we will go ahead with so many things like Terraform, Docker, Kubernetes. So these are all the different components which will be combinedly called as DevOps. So now why we are going with the cloud? So cloud environment is very easy for us to work around. Okay, so it is not mandatory that you have to learn DevOps only to work with the cloud. So right now, whatever the company that I am working around, in that company, I am working with the physical servers only. I don't have any cloud instances. So it's an myth saying that the DevOps should be integrated with the cloud. But yes, if you learn the cloud, if there is a company who is working around with AWS and their services are all working around with the AWS or else any cloud instances, then it will be helpful for you to learn the cloud and DevOps. Okay, understood?
Yeah, basically it's kind of a process. It's a DevOps is a process to uh, like automation, something like that. You have
Automation,
to,
yes.
yeah,
It's like a process of creating
various
the
tools.
application. Okay, starting. So the developer will develop the application. So it is like a software development lifecycle. So the developer will develop the application and he will push the code into GitHub, and then he has to build the application. If it is a Java application, you will use the Maven tool. If there is a Node.js application, you will use the Microsoft tools. Like that, you will build the application. Once you have built the application, then what you will do? You have to run the application. For running the application, we don't want the servers. Instead of servers, we are going with the containers.
Containers. Okay.
Okay, so here containers are nothing but the Docker instances. So to manage those containers, we need an orchestration. So for example, you if you went for an orchestra, music orchestra, I'm talking about the music orchestra, there will be an orchestrator who is holding a stick, and he will be moving with the musicians, which means he is a manager. So in the same manner, to manage your containers also, we want an orchestration tool that is called as Kubernetes. Okay, so which container, if there is a container downtime, automatically a new container has to be created. Everything will be set by the orchestration tool. So simply what I will say here is to manage your container orchestration, also to orchestrate your entire containers, we will go for the Kubernetes. And later to implement all this, see, if you see all the processes, Git is a Git, Prometheus or Grafana monitoring tools, or else SonarQube, which is also a testing tool, or else build tool like Maven, Docker, and then Kubernetes. These are all apartly, they are different. But if I want to combine all of them into a single execution process, then we need Jenkins. Jenkins is a CI/CD pipelining tool where it is going to pipeline all the processes starting from the Git to Kubernetes. Okay. So these are all comes under your DevOps. So in DevOps, we are mainly focused on the application implementation process that will comes under the Docker and Kubernetes.
Okay.
Yes. Understood? Clear?
Yeah, got it.
Sir, like do we have an we'll do hands-on on microservice setup, like in front end is one container and back end is another
Everything will
container.
be a hands-on process only. Okay, I will not provide any project, but whatever we are discussing, we will work around. We have to create the manifest files and we will work around with the configurations. Okay. Yeah. I hope you understand this session. We'll meet in the next session and discuss about the Docker containers, how to install the Docker. And tomorrow will be the last free demo for you. And from day after tomorrow onwards, you will have the paid sessions. So have a nice day and we'll meet in the next session, guys. Bye.